Hello there and welcome to Lesson 7 of Elements from the Sea. This lesson is all about the physical properties of the halogens. Now this does assume that you know what a physical property actually is. So what I'd like you to start with thinking about is what actually is a physical property. It's likely from GCSE that you have heard of a physical property, or you might have talked about it in terms of a physical change. So feel free to pause the video now and have a think about what we mean by a chemical and physical property, and feel free to record a few examples of each. So what do scientists mean by a physical change or a chemical change? The idea of physical and chemical change was introduced back in year 7, or should have been introduced in back in year 7, and recovered at several points throughout the GCSE chemistry. And what you may have done is had a load of different chemicals and materials and seen examples of physical and chemical changes. With a physical change, we are looking for something that is pretty easy to reverse. It hasn't actually changed the chemical structure of that matter. It might have just changed the shape or the state. Whereas a chemical change, something new has been made. For example, a new smell, some bubbles, a colour change, or a change in energy. Those are the main factors we are looking for when we're observing a chemical change. A new chemical being formed as seen by a colour change, the giving off of a gas, releasing of heat, or taking in of heat, because obviously we have got our exothermic and endothermic reactions there, or you can get reactions that give off light instead. Photochemical reactions, for example, a reaction with luminol is fantastic at giving out light. That is an example of a chemical change. But what we should be talking about right now are the chemical and physical properties. These are linked to the changes. So what is the difference between a chemical property and a physical property? Physical is, just like with a physical change, it is a property that does not change the chemical nature of the matter. So for example, the colour that a material is a physical property. Any smells it gives off, smell is related to the volatility of a chemical, in which volatility is just a way of saying how easily it is to turn into a gas. So a chemical that is extremely volatile will turn into a gas very readily. The melting point, freezing point, condensation point, whatever you want to call it, that is defined by the interactions between the different molecules, and that the intermolecular forces of attraction, I should say, the intermolecular forces of attraction are a physical property. Now, as yet, we've not really talked about that many different types of spectroscopy. One of the types of spectroscopy is called infrared spectroscopy. And we will do this in more detail another time, but infrared spectroscopy, basically you fire an infrared beam, for example a laser, at a sample, and the sample of a chemical will vibrate with a specific energy. That energy level is given off and recorded by a machine. And since that is based on the physicality of that compound, i.e. what bonds it has present and what the configuration of those bonds are, that is fixed until a chemical reaction happens. So the physical property of infrared spectra, that is definitely a physical property. Magnetic properties. Now, I'm not going to go into magnetism now. If you want to read up on more of what makes something magnetic or not, go for it. There's some hardcore science there, and it's really interesting to look into, but not actually discussed in the scope of our course. So I'm just going to leave that there. Opacity is its interaction with light. So if something is opaque, then it is not see-through. Okay, we've got transparent, translucent, and opaque. That's what we're talking about when we're talking about opacity. It's interaction with light. Viscosity. Viscosity is a word that you should have come across at GCSE. It was linked usually to oils. Viscosity is how well a liquid or a substance flows. Something with a high viscosity is considered to be very thick and viscous and just doesn't flow particularly well at all. Typical example would be something like treacle. So treacle, if you've been making flapjacks at home or anything like that, trying to get treacle or honey out of the jar and into your cooking is a bit of a pain, isn't it? That's because it is high viscosity. Where something with a low viscosity, such as water, flows really easily, sloshes about very nicely, flows out of a tap, low viscosity. Density is somewhat linked to viscosity. They do interact with each other, the idea of density and viscosity, but density is how tightly packed the particles are within a set volume. So the actual calculation for density is mass divided by volume. So you might have grams per decimeter cubed or something like that. And that is usually represented with a number. So, for example, density of water is 1. Okay, anything more dense than water is going to have a number higher than that. Less dense than water, it's going to have a number lower than that. Okay, that's just density. So those are the physical properties. Now, chemical properties. Chemical properties do change the chemical nature of the matter, so the materials itself. And actually, this is summed up really nicely. That's a bit of a la-di-da way of putting it. It's summed up really nicely down here. Basically, if their characteristic can only be seen by doing a chemical reaction, then it's a chemical property. Physical properties are very easy to see. You just look at the item and it's like, oh, it's there. Or you apply a tiny bit of energy and yeah, there's the physical property. With a chemical property, you have to do a chemical reaction to make it exhibit that property. For example, reactivity. We should know that the halogens and the alkali metals are both very, very reactive. They are very reactive because they have got nearly a full outer shell. Each of the halogens and the alkali metals are only one off having a full collection of electrons on their outer shell. So they are very reactive. You can't necessarily see that until it starts doing its reactions. Toxicity, i.e. will it poison you? Is it toxic? Now, biologists would argue at this point there is a difference between toxicity and poisons and toxins and venoms. Again, that is not in our scope. I'm not going to talk about that today. Higher level chemistry, we do look at that in a bit more detail. But toxicity is basically toxins will interact with your cells in a particular way. And what they will do, each toxin does different things to different cells. For example, snake venom disrupts neurotransmitters in the brain. Whereas something like carbon monoxide is toxic because your red blood cells, the place where the oxygen molecules get in, we can consider it a little bit like an active site if you're used to talking about enzymes in that way. There is a site where the oxygen molecule gets in. If a carbon monoxide molecule gets there instead, it will block that site, and so that red blood cell can no longer uptake oxygen, therefore cannot take it where it needs to go, therefore you can't do respiration. That's how carbon monoxide kills. But toxicity there needs an interaction with the cells, and when it's interacting with the cells, it's reacting with the cells, so we can only see that when it's active. Flammability, i.e. how easy does it ignite? You can't tell how easy it is to ignite unless you have a source of ignition, i.e. a match. Other sources of heat are available, obviously, of course. So if something sets on fire, that is a chemical property. Don't forget, chemical property like flammability, if we've got a combustion reaction, we are talking about a fuel source reacting with oxygen. So flammability is related to combustion reactions. Oxidation states. We have talked so far in this unit, back when we were still in school, about oxidation states. Oxidation states are not directly observable. What we have to see is an indirect observation where we change from one oxidation state to the other and potentially observe a colour change, which a colour change is a sign of a chemical change and therefore a chemical property. The stability relates to the reactivity again. However, it would not necessarily just be reacting with a specific other chemical. It might be, does it undergo thermal decomposition, i.e. if you heat something like calcium carbonate, will it break down to form calcium oxide and carbon dioxide? So stability and reactivity is a similar sort of concept, but with stability, you tend to talk about it just being one chemical decomposing to another one. The bonding itself, so whether it be ionic, covalent, metallic, that can change depending on what you've got reacting with what. So yeah, obviously that is a chemical property. And the pH, don't forget, pH is just a measure of the concentration of H plus ions. For the H plus ions to be liberated, a chemical reaction will have happened. Okay, so the pH we can see by doing chemical reactions, therefore it is a chemical property. Okay, so that's a very quick breakdown of what we mean by chemical property and physical property. And what you lot need to be able to know, recall, and actually remember is the physical properties and the chemical properties of the halogens. Now for today, we're just having a look at the physical properties. So what you need to do. If we were doing this in lesson, at this point I would demonstrate some samples of chlorine, bromine and iodine to you. It's a really lovely demonstration. It's a real shame we can't do it because it's very, very pretty and it's lovely seeing it up close. I will pop some videos with this so you can actually see those. But in addition to that, these are the specification points down here of what we must, or what you must, be able to do. Description of the physical properties of the halogens, appearance and physical state at room temperature. That is covered up here. Job done. You also need to include the volatility, not forgetting that volatility is just how easily it turns from a solid or a liquid to a gas. Iodine in particular does something a little bit special with that. I need you to find out what that is. You also need to find out, is it soluble in water? And is it soluble in organic solvents? By organic solvents, we could mean a whole range of different chemicals. For now, I'm happy for you to do it just with cyclohexane. Okay, so you need a summary. I'd advise doing it as a table like this, but you need to add in volatility, solubility in water and in organic compounds. That is it for today, ladies and gents. The next lesson, so Elements from the Sea, Lesson 8, the chemical properties of the halogens, is already available on my YouTube channel. Check it out. I'll pop the link here on the screen somewhere. That's it for today, ladies, gents, girls, boys and others. I hope you're having a lovely day and I hope you all keep yourselves safe.